Assalamualaikum. We are from Group 4. We will present fluid level system. So we take a look at chapter 1, which is introduction. Modeling and simulation. Modeling and simulation theory involve creating and using modern models to simulate a behavior of actual system using various type of models such as mathematical, physical, and computer-based model. Second is abstraction. Is the process of simplifying a complex system by identifying the most important variable and relationship and modeling term. Third, fidelity refer to the degree of which a model represent the real world system accurately. High fidelity models are intricate and detailed, whereas low friendly models are simpler and may contain more assumption. And lastly is validation and verification. Are the process of testing, evaluating the model to ensure that it represents the real world system accurately and its prediction are accurate. So next, mathematical modeling. Mathematical modeling is a process of using mathematical concept and technique to represent and analyze a real world problem system in fields such as physics, engineering, economics, and biology. Second, the process involves identifying key component and relationship of the system, creating a conceptual model, translating it into mathematical model using equation and constraint. And it involves solving it using mathematical technique to make prediction and gain insight into the system behavior. So we take a look at fluid level system. Fluid level system are used to measure and control the fluid level in containers or tank and can be used in industrial process control, chemical storage tank, and water and waste treatment. Fourth is a mathematical model can be used to represent the dynamic of the system, and simulation can be used to predict how the fluid level fluctuates over time and identify potential problem. Additionally, modeling and simulation can be used to optimize the design of fluid level system by determining the optional configuration for the performance. And here is comparison of two tank interacting and non-interacting tank. So the main difference is the water is treated as it flows through the tanks, while in non-interacting tank system, the water is already treated or in a process of being treated. So here comparison of four tank in interacting and non-interacting tank. The aim is to control the water level in the lower tank 1 and tank 2 with the two pumps, and tank 4 with two interacting tanks connect to two non-interacting tanks with having one pump of the first tank, and there is no exchange of fluid between the tanks. Fluid level in each tank will be affected only by the inflow and outflow of fluid within the tank. If interacting, it means there are in some exchange of fluid between the tanks. So for chapter 2, we have a real problem, which is mechanical translation system, medical device, mechanical rotation system, wind turbine, electromechanical system, elevator, fluid level system, chemical process control, and thermal system, refrigeration system. So we take a look at mechanical translation system are used in medical device to provide persistent movement. They are designed to optimize using modeling and simulation to improve performance such as range of motion, precision, and dependability. Second is wind turbine, which is a machine that turns wind energy into electricity. It has a rotor with blade, a shaft that connects to generator, and a tower. Simulating its behavior, potential issues can be identified and performance can be improved by reducing vibration, noise, and increasing output and dependability. There is elevator, a machine that moves people and items between floor and building. There use electric motor to lift the elevator car up and down in the vertical shaft. An elevator system include the car, ropes and chains, counterweight shaft and electric motor. The rope chain are turned into by electric motor in the lift car, and the counterweight balance the car's weight. The elevator shaft is vertical structure that house of the car and ropes change. And our project will focus on fluid level system, which is non-interacting fluid level system, are used to monitor and control the level of chemical intent to ensure the proper reaction and prevent leaks. The system uses sensor and control system to measure regulates the chemical flow into the and out the tanks, allowing for optimal reaction and control production of specific products. So lastly is thermal, which is refrigeration system was chosen. It's transfer heat from a low temperature space or substance to a higher temperature environment. By simulating its behavior using modeling, mathematical modeling, and modeling simulation, potential issues can be identified and performance can be improved, such as by reducing energy consumption and increase safety.
Next, I will explain for the chapter 3, which is method of assessment. This is our block diagram. First is stat input, and then it goes to the controller. After that, three tank non-interactive level system, and it goes to the back. And the last one is system response. The below one is the block diagram for three non-interacting tank system. The upper one is we propose system for the block diagram, and the below one is the block diagram for three non-interacting tank system. Okay. The next is our block diagram with complete tank, which is first is stat input, and then it goes to the controller pump. After that, it goes to the K1 over R tau 1 S plus 1, and it goes to the uh, H1 S and 1 over K1 K Q2 S, and it goes to the second step also. And the last one is stop response. It also have a sensor. Next is state space and transfer function. This is our calculation by manual, by hand. First is input signal, input flow, the first tank, and then it goes to the tank 2, and the last one is tank 3. So this is our calculation for the transfer function. Hs of Q3 S is equal to R3 A1 uh, R1 S plus 1, and uh, times with A2 R2 S plus 1, and the last one is A3 R3 S plus 1. Next is state space and transfer function. After we got the transfer function, we will use the formula for the next step, which is state space. This is our formula, and this is our calculation by state space, and this is our final answer for state space. Uh, Next is state space and transfer function also. But this one is a resolve matrix, uh, different with state space and transfer function. But the calculation also from the we get the value from the state space and transfer function. Next is chapter 4.
Okay, for chapter 1, result and discussions. In this chapter, we're utilizing the Mallet Simulink to run the simulation in order to gather the responses from the three tanks connected with a PID controller that are non-interacting with each other, as the diagram as chapter above. For the initial output for tank 1 is 0.5 seconds, tank 2 is 1.0 seconds, and tank 3 will utilize it as 1.5 seconds. The PID controller constantly assesses the fluid level in the tank against the intended set point via the feedback loops. So we get the loops increasing. We run the analysis through the four different lines, which one indicate the three of the tanks, and another one is indicate each one of the tanks. From the response, 0.5 blue line represents the first tank only and rise through the time below 0.8, but still in between of 0.7 and 0.8. Red line indicate the 1.0 of second tank, that second position below the first tank. Generate a data for decreasing time, the 10-second goes from 1 to 0.3. As for the third tank, represent at the time 1.5 seconds. Also show the decreasing in time down to 1.2 seconds. As for chapter 5, in conclusion and recommendations, For the MATLAB to verify and validate a system on the working principle, the sensor system that monitor fluid level system for the multiple times, there is part of error in the Simulink that make us hard to validate the data, like the tunes we get it. In order to get the tunes for the PID controller, is appear as an error. So the analysis for the amplitude is negative. Control system regulate the flow of liquid between the tank and ensuring proper distributed amounts. And a backup power source such as generator to make sure that system can continue to function even if the power is go out. That can be as a recommendation for another type of tank or fluid level tanks to create in the futures. Thank you. That's all from us.